I just got an order in today for my solars that we're building. So, but it took a long time to get that stuff in because, again, you have to have ID and all. It was a mess, but we got it. That's the whole point, is that now I'm going to be getting more equipment in now that we got the connections to get more equipment in.
Okay.
And it's a language barrier.
Yeah. By the way, that side they speak. I think they don't use English.
No. No one here barely. Well, it's a few people who speak English, but not much. So. Did you start the video? Because I don't see it moving.
I did. I don't know if I did start another live stream. I'm not sure if it's live yet, but I think it is live. You're watching the video. That live ended, so you'll have to go to YouTube. Yeah, it is. You'll have to go to YouTube and search me again. Like go over to my channel again. Yeah, then it I think there's where you'll be able to find. I see it is on. I thought maybe it was on private. If you just go to my channel, then you go to the live section, I think you'll see a newer one.
I don't see it yet. I'm looking for the live. Let me go to live.
Yeah.
I see it. Okay, I see a new one.
Yeah, there's a new one.
Yep. Okay.
So
yeah, I see it.
Yeah.
So where are you at the video?
The video was at minute. For me, I was at minute 4. I don't know if for you on your side you had to what point. I had played it up to minute 4. Where it stopped, yeah?
Okay.
So
wave your hand.
Yeah, I'm not sure if I'm stuck or not, but I'm trying to see but I think you can see me. I don't. It looks odd.
I see you with you got your phone in your hand, right?
Yeah.
Okay, so I'm on. Okay, there you are.
It's kind of. I think I should. Oh, it's when it's sending a notification. I think I should have. There's something I did, but I think it's just okay. But the good thing is I'm moving, yeah. So it's okay.
Yeah.
I did not start like another live. I just restarted the other one. So and I think it is why it looks like it has some delay, or I don't know. It looks odd from my side, but I think it's working. So you okay if I play the video?
Yeah, play the video.
Okay.
You'll see this on the monitor when I set this up. The energy goes back up into the system and then back into what? The battery. And that is a loop.
Okay,
That's
yeah, I
what
see
we're
it
calling it.
You're seeing it moving?
I think I see it moving.
You
yeah, I'm pointing down to the battery, and I'm showing the charge controller, and I'm showing the 4 wires at the battery.
Yeah.
So that means all the energy is coming from the battery right now, and I'm going to loop it over to the solar port.
Yeah. So
that's what I'm waiting for. Is to loop it over.
You say that you're in a few minutes you're going to explain if it's a closed loop or not. You cannot be able to get in. ID is asking if you can get on. The internet speed was.
I see him. He said, "Yeah, it's not. It's the camera and all that was not working."
Yeah, ID stuff wasn't working on his side. Although I can't see the comments on my side. Fuck, I fucked up. I can't see the comments well, but yeah. But I see your comment ID. I can't put it on the screen, but like he says, his camera wasn't working well. But just like hit the like button so that it does the recommendation thing. Let me continue playing. So, but so far I feel like it is a closed loop because you're saying that it is a loop. But let me continue playing. Maybe I will see. You said you're about to explain.
Yeah, I'm waiting for you to see me plug that those two jumper cables over to the solar side. So I'm waiting for that to see that.
Okay.
Loop. Just like we did the loop with the solar last time, we used the battery, one of the solar, and then we plugged it back into the battery. We're going to do this on a big system, which is an MPPT, and it makes a difference on how this functions. So let's get that set up. And remember, part 1 was showing the battery. Part 2, showing the jumper cables. And then part 3 is to actually get this set up so we can see what
You
the
do
heck
see
is
4
going
wires,
on.
correct?
Yeah.
You do know it's all in the same as the battery. The positive and negative of all 4 wires is at the battery.
Yeah.
See what the heck is going on the meter up here. Okay? And I just want to get a good shot on how these wires are set up. Okay? Positive, negative. Okay. So we got a good shot of that.
I'm just
So
making
we
sure
know
that everybody
is easy.
following along that these are all at the battery terminal. I wanted to be specific that you know that all these wires are at the battery.
Yeah, I think they do. I think they do. So it was just the thing is I continued playing from the other live stream, so I did not start it afresh, but I think they do.
To follow because we don't have wires like I did on last time I just demonstrate this. So we got short wires and it's easy to recognize. Let's set this up.
You see, Lloyd,
Okay, we got
I told you YouTube will play ads anyway.
it all set up. And we're ready to see
Okay,
what is going
you
to
see
happen.
Is that the solar part? You see me see the
Okay.
loop?
You see?
You see where I looped the jumper cables over?
Yeah.
Okay, so that's the loop you were talking about. That's the loop.
Okay. So yeah,
You went back. It looked like you went back.
no.
I wanted you to keep going.
I just paused.
Okay, I just want if you see the 4 cables. You understand the cables. You have the one cable that's going to be connected to the battery,
Yeah.
and you have the other 2 cables, which is at the solar part.
Yeah, you have.
So that answers one question. When I plug that battery in, either it's going to blow up or it's going to accept the DC. But that's what I'm talking about in the video. So if it comes on and everything is running well and you start to see what it on there and everything's working fine, that means that DC is DC. So if you go on, you hear me talk about that, okay?
Yeah. Is it just like the other? I think it's just like the other system. The only thing, the other system, you add the step down converter in between these two. For the other system, but this one you're taking it directly. Let's see.
Yeah, because you see you got a comment in there and it says that this shorts out the charge controller. So let's see what it does. That's the whole point of why we're doing these experiments. If it's going to short it out, it shouldn't work. So That's why I said if we get past this, we should be able to plug it into the battery and see what happens.
Okay.
So we understand this is the battery terminal, and we understand these are the jumpers jumping from the battery over to the solar, battery to the solar. Okay, so when we plug this in, is this going to blow up? Let's see. Okay, it's boosting up. Push button enter, and look at what's going on here. It's saying that it is 37.58 volts
Now,
in the
see how
battery,
clear that is?
and that
Look,
it go over
37, and it's higher at the battery, and then on the other side it says 37.4.
Yeah.
The battery's not charging, and there's no watts coming in, and no amps being produced. You agree?
Yes.
Okay. So we go on. I'm going to bring an outside source coming in, because this is a loop.
No, the
This
amps,
proves your point.
the amps being produced.
This proves,
Wait, I mean, if it is just using the same amps from the same battery.
yeah, that is right now. It's just a loop.
That's 7 volts 0.00 A, or it's showing 0 amps. Okay, I see.
Yes. Okay. You can see. You can see. It's at the top is the 0.0 watts. The W is watts. It's at the top. Then it's saying the voltage coming in is 37.4 volts. In the middle, the 00A, that's amps, and that the battery is 37.58. So it's showing you everything. You can see it. The other ones with these PWMs, you couldn't see all this information.
Okay, so ID says that we had a fault here. Let me see.
Say the question again.
Okay, it's boosting up.
No, ID was saying that there was some sort of a fault. So I'm trying to go a little bit back to see if there's something. It shows that there was a fault, so you did override it. But anyways, that's not the point. You're still around.
Yeah, I'm listening to you. You said it said if you read it, it says the battery overload discharge.
The battery over discharge protection, like it's as if it doesn't. It's saying that battery over discharge protection.
Yeah. So then I say, yep, I know, and I click the button to proceed.
Let me see. Battery over discharge. That's battery.
I did not turn off the charge controller. I pushed the buttons to confirm that I see the fault and to continue. Yes, it is a safety.
Oh, it's not even an issue.
No, it's not. If you continue, you can see that it's working.
Yeah, I've checked on AI. I've checked on AI. AI says that just shows that your battery is like your battery was. Let me share that before I was trying to understand like what that error means. Yeah. So on the fault, but it's not really an issue.
No, it's not. That
It says this. It says that I think you can see on the screen. Battery over discharge occurs when a battery continues to supply power after its voltage drops below the manufacturer's safe minimum limit. This excessive draining often resulting from maybe when it was overused or something. So it's like it was just telling you that your battery is like almost empty, below what is required to run the. Like it was just telling you that your battery is low, I think. I didn't say you turn the charge controller shuts down because it detects high current. No, it's not. Is it a detection of high current? No, it says that comes on to avoid the pitfalls of over discharging. Many modern devices and power systems utilize over discharge. Oh, battery management system. Oh, I see. To avoid pitfalls of over discharging, many modern devices and power systems utilize over discharge protection. So it's like it. Battery management systems. While the totally brick batteries often require replacement, some deeply discharged units can be revived by slowly low amperage charging to safely. So I think it was just disconnected because it so the voltage was too high.
it's just asking me if I accept it or not. So all I had to do is put enter, and that means that I accept it, and it goes on. So you have to continue the video, and you see that everything is functioning correctly.
Yeah, I'm continuing it. So let me confirm it. If I thought it wasn't an issue anyway. If exit default.
When you ask those questions, you should put in the type of the name brand of the charge controller, what the charge controller is. Is it MPPT? That way it has more information to answer it correctly. When you give it just anything, it could just pull it from any kind of charge controller in the world because it doesn't know exactly what you're talking about.
I can screenshot and upload the image.
Yeah, like I said, the more information that you give it, the better answer it can give you. Because if you say it's name brand, it's an MPPT, as much as you can get, and then it can give you, oh yeah, this is brand does this, or it doesn't do this.
Cecile, how are you doing, Cecile? I see today you're here, man. There's someone called Cecile. I think you were saying that maybe you have something, but you should be careful for your life. Cecile was saying that sometime back, Lloyd. In one of the live stream, there's a live stream I think 2 weeks ago. You say that Lloyd should be careful, people will come and kill him. If you press enter, the right button with the arrow icon, I think that's the one you pressed.
Yes, I press enter.
Is on the screen. A few things will happen depending on how you press it. A simple click clears the screen. Pressing it once briefly usually acknowledges or temporarily dismisses the active fault prompt banner so you can view other system metrics. So it's like, are you okay? So it's not really an issue. It's not really an issue.
No, it's not. I told you that.
It's not really an issue. So let's continue. Let's continue. Cecile, which trap did you set in motion?
Push button enter and look at what's going on here. It's saying that it is 37 point.
AI says that if you accept and press it,
Yeah.
AI says that
Now,
if you press it, pressing it once briefly usually acknowledges or temporarily dismisses the active fault prompt banner, so you can view other systems
correct.
metrics like voltage or current charging amps. It will not fix the underlying battery issue or force the controller to start outputting power again.
He's trying to make an issue out of something that's not an issue. But it didn't matter because the whole point is it was to do the experiment. So now the experiment is back up and running, and it's showing everything that's at the battery, and that it's showing what's going into the solar part.
Yeah. And let's continue to see
58 volts in the battery, and that it go over here. It's saying the solar, which the battery thing is 37.4, which is a little drop down because of resistance. So that means when they talk about having more power here than is going in here, it's wrong. You're going to have loss. So, but we don't have that much loss. Okay? So, how is this being weaker going to charge this?
why BD is current off. That's the question from ID. Though it's a good question, Lloyd. Why is current 0.00?
Because it's not moving into the battery. That's why the current is not 000. If nothing is going into the battery, it's not going to read the current. It's just sitting there at 37 because it's below what's in the battery. That means no energy is pushing into the battery. So you don't have any watts going into the battery and you don't have any current going into the battery. It's just acknowledging that we have 37.4 volts at the solar point. That's all it's acknowledging because we did the loop.
So I just tried to ask AI again the same question, like why is it so? Why there's why is it 00? And AI says that it's because let me just read. The current is showing 0.00 amperes because your AMP and NVT charge controller. Right, MPPT or what? Oh, it's getting the model. Charge controller has physically locked down its electrical terminals due to active over discharge protection code. So basically, it means it's off.
Okay, so if you continue the thing,
So
so
it says
it's off.
It says sitting.
You're making this up now because
No,
you're saying it's
I'm not.
off, but you're seeing it.
I'm not.
So I'm telling you
I'm not.
that it's not putting energy into the battery. Therefore, that the circuit is not complete.
No, I'm not.
That means no energy is going into the battery. As soon as energy start going into the battery, you'll start to see the amps and watts.
I'm not saying like I'm making up my own. I just asked AI. It said that hitting the enter button only acts as a user acknowledgement for the screen interface. It does not force the mechanical circuit to turn back on. The 0 amp readout will stay at 0 for two distinct reasons. DC load current is 0.00 ampere output. The controller's main job is to stop draining, and charging current is 0.00 input. If the 0.0 is, you are really look at this for the solar panel output, it means the system is not pulling power from your panels. This happens because, but I know you. Let me play.
What I just said.
Let me play and continue because you haven't connected. But basically,
Yes.
yeah, you haven't connected the solar.
I'm telling you the same thing. It's like you didn't believe me. Then when it tells you, yeah, it's not pulling current, so it's not putting anything into the battery. Therefore, it's not going to read the current.
I'm also learning. And I'm asking AI these questions,
Okay.
and it is answering.
Yeah.
So
it's okay. You're learning.
So it turns out it is like switching it off. like it's, yeah, it turns out it switches it off. So I thought that maybe you just acknowledge and you override and it continues working, but that's not the case.
No, it's not the case.
So AI, you see when AI talks about such things, you're okay with them, but others, with this video, the question is okay. Cecile, let me play first.
It's not by itself. So what is it good for? Because I'm going to put up this video of, a picture of this video that I did, and I'll put it a link to it in the description. Why?
Now,
Because I did
you
this
said you can hear
before,
me
and the
talking,
number.
Chris, right?
You're saying?
You can hear me talking, right?
They're saying that they can't hear you.
No, I'm seeing the video. What am I seeing in the video?
Oh yeah, I can hear you talking. I'm playing on. I have headphones. Or you want to hear via?
Okay.
You want to hear via
So
the microphone? This phone.
no. Okay, so you see how I put that link in? That's another video of mine where I put
Yeah.
something in a loop
Yeah.
and show that loop runs down. So I'm just showing that I did this experiment in another way, showing that if you put something in a loop, how long it will run in the loop. And I reconstructed that one in a newer video.
So
Not as big as this one, just something small. But I'm showing you, okay, this is a loop. So far, this is the loop you're talking about. No external energy is coming in. So the next step is to do what I did with the solar panels. This is what we were talking about. When we add the solar panels to this system, what is going into this system?
yeah.
The only way to do that is to see the voltage and the amperage that we're going to put into the system so we can see it. That's why I said this is a simulated solar. It's
So-
DC, and it tells you what voltage and what amperage is now going to be pushed into this system, and does it contribute to what the battery is already saying is the 37 point. If it doesn't contribute, it should do nothing.
Yeah.
It should zero out and sit there just like it's sitting there right now. But if it contributes, okay, then it's going to start charging the battery.
Yeah, so I continue playing the video because right now as it is, it means the power output will be like 0. The power output.
Right now, we can see the zeros on the thing. It says 0, right?
Yeah, so the power output of like what you're inputting in is basically 0 or nothing.
Okay,
Like
because it's coming from the battery. Okay,
yeah.
so let's keep going.
Like these two that you're saying looping. So it's basically means looping is doing 0.
Yes.
Okay.
Going in here is wrong.
So we're showing that's exactly what I'm doing, a loop.
Yeah, there's a point you're going to introduce the solar, so let me play and see.
Wrong. You're going to have loss. So is that, what is it good for? What is this good for? You looped it, so it doesn't make any difference. What can you use this for? That's what we're about to describe, because it goes to talk about the solar that we were making, the ones we were building ourselves. And they said, why would you use LED lights to run your solar? You're going to be at a loss. You don't get full sunshine.
That's the solar panel I
Well,
made
guess what?
by hand.
Okay.
See that 37? Your solar has to go from 0 up to whatever it puts out. Okay? Mines do not. Mines start out with 37 volts. Okay? It starts out that way. So now we add to that. So now what we're going to do is add to the solar part of this out. Okay? Mines do not. Mines start out with 37 volts. Okay?
Is that true? Okay.
Are you following along so far? Are you understanding?
Yeah, you're saying that your input solar panel will start at 37, which again, it doesn't make sense. But let me continue and see.
Okay.
Yeah, because
this is the part
I think you're talking
make sense.
that way you'll be talking about again voltage alone. But let me continue and see.
Exactly. So we'll get to see what it does when we add it.
Okay.
And how much we're adding.
Let's continue playing the video. On the other live stream, I got 1 subscriber. Nice. Continue, see.
It starts out that way. So now we add to that. So now what we're going to do is add to the solar part of this. And we're going to put one of our simulated solar so we can see one of these. So we can see how much energy we're actually putting in this and how much we're saving. So we can see everything that's going on. Okay? So we'll come back in another part and have that all hooked up. Okay, we got it all set up. And the battery is on.
Now this is the outside source.
You're saying which one is the out? This looks like
that thing sitting on the side there. The thing I'm saying this is simulated solar. That's the outside source, and you can see it at the solar part, which I did in the first experiment that you were asking about. And you said the 17 volts just went to 0. And now we're about to see if it's going to contribute or it goes to 0.
Okay.
Let's see if we zoom in, turn on the backlight, that we see that we have what we had before. 37 54. This went down just one because 4 now 3. Still 37. But if we looked at this battery charger, we see 37.3, which is exactly what that is. That's because energy is feeding back into this. No amps or real volts is being pushed in this because I turned it all the way down by this rheostat. So let's see if we put some power in there. Okay, I just wanted to get it all set up here, and I also wanted to bring up one more point. One, this is the energy in watts, which we have this plugged in. Let's follow the cord back up to our isolation board, and you see that's what's running this. Okay, so we understand that this right here has 0.5 thing. That's going to go up, but that's why we want to measure this. Okay, so let's put on this backlight and see. Once we get enough energy in here, which we means that we have to put
shore power.
You're saying? You said something.
37 volts. this will start going up. So let's see if we turn this up. Oh, there goes some amps. And this is now turning up. And you see how it jumped to 5 at the end there? See how that jumped to 5? It was at 3. This now battery is charging. And you can see it's going up.
Oh, we see some amps.
That's all we want you to understand.
And we see wattage.
So we're charging using the battery energy. So we don't have to spend as much solar, because this is a solar simulator. But we don't have to think. That's less than an amp. So
Lloyd, you're saying?
The bottleneck is 37. It's never going to go over there. Even the thing is saying 37. Look at the amps I'm putting in. 0.80.
Okay. You're saying that these are solar panels?
No, I said it's a simulated, so we can see how much power we're putting in, the voltage and the amperage. That's why we used it, so we can find out what it would take to push into that battery. So are we now saying, because the 37 volts is already there, so it's not going to go over 37 volts. Now we just need to put in just a little energy into that system, and then it starts to charge.
So you're getting 0.5 watt from the grid.
Correct. I've been saying it all night that this is a closed loop. It's not a closed loop.
Okay. So yeah, I'm trying to understand this one before I continue. So basically, what I'm saying is, but these ones are, so basically this one is getting from the grid and it is outputting that 6 volts. It even says here it's supposed to output that 6 volts stroke 10 amperes, I think, into the system. So okay, let me continue. And for you now, you're saying that already in the system you had 37 volts.
Yeah, we're at 37 volts. That's what's in the system. So the battery charger says, hey, we're already at 37 volts. So if we now push energy into this system, is it contributing to the 37 volts? Because we bottleneck is not going to go over 37. That's called a bottleneck. To prevent bottlenecking, you use 2 charge controllers. So the whole point is that you said, so when I did the 70 volts, it doesn't contribute.
It said,
so either this is not contributing,
it said,
or what's going on.
It said it contributes a very small amount. That's why. So if we consider this one you're putting in, it's showing that it is it is what you're putting in is 36 volts, right? It's even showing
Yeah.
37. I think it shows you 37 or something. But the thing is,
Yeah.
let's say 36.
Remember.
So
Okay.
if you take
You
that,
see you see the 37, right?
yeah,
You see the 37. Okay. So on the other side, it said 37, right? It's at the exact same the level as the battery.
yeah,
Correct.
yeah,
Okay. So the only thing that you can put into this now is a small amount of amps.
yeah.
If you don't get one before that point, then it's not a full amp, is it?
Okay.
If it's less than an amp, it's called milliamps.
Yeah.
Correct?
Yeah.
Okay. So when you watch to see how many milliamps are going into this system, because everything is at 37. All of it is at 37. It's just a little bit higher, 37.3, 37.54. That's what the battery is actually putting out. And then when you put the battery charger on there, which is the simulated solar, it says 37 because it's reading what's coming from that solar because it's at both at the solar point. So it's reading 37.
So
if we're already at 37, that means either when we turn it up, we're going to contribute energy in it from another source. Are we agreeing?
It's more like
that battery charger is another source of energy coming in. Are we agreeing with that?
even AI, even the question that I asked the AI the other time, it agreed and said yes. But if you're using LEDs to do the supply of that power, then what you're getting in is very negligible. That is what it said. It said yes, but very negligible. Like in this case, I'm assuming this power supply is still bringing in voltage and current. That's right. It's bringing in 37.5.
Okay.
It's bringing in 37.5. 37.5 and maybe this 0.42. Right?
Okay. So we know I showed you what I was drawing from the grid, right?
Yeah.
Okay. So again, if you're not drawing that from the grid and we're not amplifying, and then we read what the amps is, that's negligible. That's what they call it. That's what they're saying, negligible.
Yeah.
So once you turn it on, what happens?
This is from a power supply. That one was from an LED powered solar. They're different. This one is
the
bringing.
numbers are not going to change.
This one is bringing.
You're trying to say the solar is not. We can't see what the solar is contributing.
Okay,
we're trying to tell you that we're trying to show you the numbers. Numbers. What are the numbers?
I saw you had some. I saw you had some panels there. So are you like when I continue to play the video? There's a section where you will put on the you will do the solars instead.
That's not what the experiment is. The experiment is to find out how much solar I need. Without the numbers, you don't know how much solar to add into the system. These are called calculations. This means that I'm trying to find out a number, and then I said if I only need 0.8 milliamps, then all I need is that with the solar. Now, somehow you're trying to say, well, it's coming. Of course, this is because it shows the instrument. It shows the fact is this is how many amps is being put into the system. This is how much it's drawing. And then does it make sense that we're getting 15.8 watts?
Yeah.
We only got 0.42 amps, which is what? 24 milliamps.
Yeah, I see. ID is saying that this is outputting 0.08 volts. Amperes. Sorry.
Okay, so when you got to go to the part where you turn it up. So when you turn it up, You can see the amps. We already know that we got voltage. It's not going to go over the 37. I don't care how much I turn it up, and I say that. It is not going to go over the 37. That's called a bottleneck. But look what I'm putting in. 0.68.
So basically the power you're putting in is more than the power you're putting out. Or what you want me to know is that it contributes.
Yes.
It doesn't matter if there is a net loss of
So what we just covered is that both of them are working together. The energy doesn't disappear. The energy is going into the battery, and we can now say how much energy is actually being drawn and put into the system, because we can see the numbers. That's why we're using the battery charger.
Yeah, we can see the numbers in this case. It is clearly showing the voltage. You see it's clearly showing the voltage and the amperage as well. So why can't you, like right now, I just switch on the video, then you measure what you're getting from the solar, because that's the input you're putting into the charge controller now on your side. In this side I see that it is putting 37.3 and 0.79 amperes. Why can't you just like measure it right now on your side and show us what we're getting from the LED? What is the voltage and what is the current? For me, actually, that's just the biggest issue. Like I just want someone to measure that one and show like this is what we are getting from here to here. Why can't you just do that? Like that one is just easy, Lloyd. You already have the setup, like just
it's
few
not
seconds.
I went into the second
Because
thing. I just can. Did you see the picture I sent you?
yeah, because for this system that you're showing me, this one is outputting power of 24. But
wait a minute. Let's slow down.
Yeah.
Did you see the picture I sent you of the system?
The one that you're saying that you're still setting up, yeah, I did.
So I changed it, right?
So basically, what you're trying to say is what you have right now doesn't work, and what you're changing to is what will work.
No. What I'm saying is one does a bottleneck, and the fix the bottleneck is at the second charge controller. So I changed it to the second charge controller because it doesn't allow that 37 to stay at 37.
You see, for this one, for this one that you've shared, it's actually putting in power, not voltage alone. It's putting in power.
It's putting in microamps.
It's putting in 0.6. No, it's showing it. Wait, it's putting in
0.79 is a milliamp. It's not a full amp.
That is 0.79 amps, yeah?
That's milliamps.
No, that's not milliamps.
Zero, it would be a 1 there if it's a full amp.
No,
it is
Lloyd,
There's a point there. It's milliamp. That is 79 milliamps.
You can say 1 meter and you can say 0.1 meter. You can say 1 mile, you can say 0.1 mile, yeah? So the 0.
Wait a minute. Ask AI.
The 0.7.
Take a picture. Wait a minute. Ask a picture. Take a picture and ask AI, is this milliamps or full amps?
Okay, this is 0. In fact, you're the one who could have even shown the units on your measurement. But look, for you see, I'm asking AI, but what this is outputting is like it's showing you're taking power. If you take 37 multiplied by 0.79, you're getting a lot of power that you're putting into the system. But for the other one, the solar thing, I'm 100% sure from
you made the mistake before, so we need to establish, is these full amps or is this milliamps? So when you ask it, take a picture, send it over to AI, and says, wait a minute, what level is this? Is this 79 amps? Which would blow up my charge controller because it's only a 60 amp charge controller? Okay, or is this milliamps? See, I know it's milliamps because the charge controller that I'm using is 60 amps. You put more than 60 amps, it catches on fire.
Oh, I know.
So it's not 79 amps.
Units. I'm not saying 79. I'm saying 0.79 amps.
Then if it's not a full amp, it's milliamps. That's the next one down. You can't, if you get 1,000 milliamps, then you have one full amp.
Lloyd,
if it's less than a full amp.
Lloyd, wait. Let me just show you the AI answer. I think you don't know how to read this thing then. I know for me, I don't know a lot about this thing, but we did some stuff about electricals back in school. There's no way that you can say that is milliamps. Anyways, let me read it here. It is a very common point of confusion, which is converting between amps and milliamps. I did put a picture this way. Is this 0.79 or 79 milliamps? Is that correct in the reading? That's what I put. Is this 0.79 or 79 milliamps in the reading? It said it is a very common point of confusion when it's converting between, it's showing how to convert between the two. 0.79 amperes is equal to 7090 milliamps. No, we are not interested in that. If the display reads 0.79 with a decimal, you can say 1 mile, you can say 0.1 mile, you can say 0.5 miles. I know for you, you know miles. Okay, if the display reads 0.79 with a decimal, the unit is amps, meaning you're pulling, or amperes, meaning you're pulling 0.79 amperes. Which is equal.
That's not what it said. I'm reading it. It says that it's 79 milliamps. That equals to 0.17.
For you, you're converting, man. For you, you're converting. Like you're converting. You're already converting it into 0. I've just taken the screenshot of what was on the screen.
I know. I just took a screenshot. It says right there that it's 790 MA.
No.
That's milliamps.
Are you watching the screen?
That's less than an amp.
You just want to argue maybe, but let me put this on the screen. I don't know. Did I took a? Am I watching a wrong video?
Wait a minute. Why am I arguing? What are you saying? I'm arguing when it says MA. It says MA.
Which one is showing MA?
MA is milliamps. Why are you trying to change that? You're just trying to make it. It's not a full amp.
I'm not trying to change anything. I'm just trying you to see. Look on the screen. Lloyd, look on the screen. I'm putting. This is the screenshot I took. It's showing 0.79. 0.79.
Yes.
0.79
is milliamps.
0.79, and for you are saying that it is milliamps. You've told me to go ahead and ask AI. Yo, AI, what is this reading? This screenshot, exactly this screenshot. I'm reading it to you, and again you are refusing. The screenshot is saying that if you have a 0 point, if you have a decimal, it is amperes. If you have a reading like 0.79 without a decimal, then that is milliamps. But again, you're saying that it's not so.
So it's behind the decimal point.
We
have 0.
Did you ever
that
go
means
to?
It's 790
Lloyd,
milliamps.
Wait, you never did any maths then. I think you know more than I do in this stuff. But this way, in terms of this is like class 1 or class 2. I don't know how you call it your side.
Wait a minute. I want you to say this on the air.
You don't.
Wait a minute. I want you to answer the question.
You don't know how to read.
Are you trying to say? Wait a minute. Are you trying to say this is a full amp?
I'm not saying it is a full amp. I'm saying it is a fraction of an amp in the form of 0.79.
So we're saying the same thing. We're saying the same thing.
No, we're not saying the same thing. If we are saying the same thing, it is 790 milliamps. What you're talking about is 790.
We are saying the same thing.
It is 790 milliamps, not 79 milliamps. What you're talking about is 790 milliamps.
Oh, now you're drawing at scars. It's still milliamps, and that's what I was trying to tell you. It's not a full amp.
No, you saw it wrongly when you did this experiment. This is 0.79, 0.79. Even AI said it. I was showing it on the screen. You said that I'm ready.
Wait a minute.
You don't know.
The reason why you're trying. Wait a minute. The reason why you're disagreeing.
You don't know how to read
decimals.
decimals.
Listening to what I'm saying.
No.
I'm agreeing that it is 790 milliamps. Did you hear it?
If you're saying 700, that one you're correct. 790.
Wait a minute.
Yeah.
But we're all talking about milliamps. It's not a full amp.
Also, that's what I've been saying. I've been saying if it's showing 0.79 milliamps, it is a fraction. It is a fraction, like a fraction of a full ampere. You never did stuff to do about fractions and decimals.
No, I'm sitting up here agreeing with you. I'm just telling you it's still in the milliamp.
Okay.
You keep trying to make it like a full amp, but I'm just saying that this is a fraction of an amp.
I'm not saying I'm not saying it is a full amp. I'm saying maybe you're not understanding me. I'm saying it is 0.79 amperes. 0.79 amperes.
And I'm agreeing with you.
And for you are saying initially you are saying that what is showing is 79 milliamperes, which
because that's what's on the screen, because it's not the other zeros don't really count.
No.
It's showing
no.
Because it's not counting the other zeros.
That's not how you read decimals. Cecil, you should. Anyways, what you're saying, I don't know, but that's not how you read decimals, man. I just said it is 0.79 amperes. I'm not saying that it is a full ampere. I'm not saying 1 point.
Okay, so we're agreeing that it is 790 milliamps.
Yeah, which is
correct?
Which is
You're
790 milliamps. That is correct. Okay. Now, if you calculate power for that, what you're going to get will be something like I think it will be, was it 20 something? But now you see when you put in the solar, if you are just using from LED solars, what you're inputting into the system, it will not be 0.79 or 790 milliamps. If I'm to put to you in milliamps, it will be 0.002 milliamps.
No, Chris, it's more than one solar. Am I right?
You're saying what is more than one solar?
Yeah, wait a minute, because I sent it to you. This is the reason why I told you to do the homework.
No, that was AI.
I had AI.
I just asked.
Wait a minute.
Let me
answer your question. Let me answer your question. You're asking me about the solar.
Yeah.
I said I sent it to you because I needed you to see that when you add a bunch of these solar panels under LED lights, since these solars put out 27 milliamps a piece, that is not just one single solar so when you put them in parallel, you're adding up the amperage.
This is very simple. I can just put you on video right now, then you measure it for us. We see like what is the voltage you're getting, what is the current you're getting on your side that is coming coming from the solar. You can just do that.
My video is not.
You showed a few days ago you had a system working, yeah?
Listen, let me answer the question.
Yeah.
What I'll do, because my video is not working,
do a video show
you the amperage.
You're on WhatsApp.
Show you the amperage in the video.
I can switch
the solar itself.
I can switch on WhatsApp. You can also switch, it is working right now. Then you just measure and
But you just heard me just say that. I can do a video that shows the amperage of the solar. Again, when you put solar in a parallel situation, you add up the amps.
In the situation of what you're doing, like what you showed, there's no amperage coming from the solar. Even AI said in your case you're getting zero. I think it said 0 point something.
You know what?
0.0.
You know what? You know why it's not showing amperage?
It said
Because it's a PWM. It's not a MPPT. So you're drawing at straws. The whole point is that the system was charging.
it said
And
0.
it showed that it was charging.
It said 0.05 amperes. What you get from your solar. You know, Lloyd.
Look.
Look.
Wait a minute. Then you just said it was at zero. So if you're saying it's at 0.0, where'd you see that at?
0.05 amperes. That is from AI estimating and calculating the losses that you did when you are doing the first that latest prototype video. So it did the estimation and the calculations, and roughly it says approximately.
Wait a minute. You now saying that I got losses. The point is that you said it wasn't contributing. When I showed you that it is contributing,
it said no. You're trying to switch my words. It said it is contributing, but a very small amount. Remember what you are contributing. What you are contributing in was 17 volts and 0.05 amperes. In this case, what you're showing me from a power supply, you're contributing 37 volts and 0.79 amperes.
Chris,
there is a difference between 0.79 and 0.05.
Chris.
Yeah.
Chris.
Yeah.
Where did you get the 0.5 from?
The 0.05 is like AI did calculation on your system based on the losses and everything, and the estimate, the rough estimate, that is the approximate, is 0. It's not 0.5. It's not 0.5. It is 0.05 amperes, which means it is 50 milliamps.
What I'm asking you is, did you see that on the system?
You did not measure. Like all of you are afraid to measure. I've had Love Loyal. There's that guy who called me an NPC. Whenever I tell them measure, all of them are afraid to measure current. Right now, Lloyd, you can just measure current right now. You have the system. You showed that us a few days ago it was running. Why can't you just measure it right now? We see.
Wait a minute.
Yeah.
You
want to explain it in words. You want to explain it in words. When you can just measure.
My video is broke, so you're saying that I won't show it.
No.
I just told you that I was going to do a video and show the amperage. Then you now go back and say, "Oh, show the camera, You knew camera was broke."
No, I'm talking about the WhatsApp camera. I'm here. You can see me. You can do this, and then I'll put you here on the screen like this, and we can be able to see it. I'll put you just here on my phone, my camera screen like this, and you can be able to. People will see you very clearly. Let me increase the brightness, because you see every.
No, I cannot see that. I just see a reflection.
Oh, it's because of the light. It's because of the light. Let me do this.
Chris.
Yeah.
Chris.
Yeah.
You're learning this system, right?
But I know maths.
Everybody's seeing it. It's just a big light in there. Wait a minute. Listen to what I'm saying, Chris.
I know maths. I know maths. I know maths. Here, look. Here you can be seen. Just switch on the camera. I know maths.
So the whole point is, wait a minute.
I know maths.
When I show you the system, they're putting out amps, right? Because what you're doing is you refuse to go back and read what I sent you.
No, look,
you did. Let me say what I sent you. What it said.
Those are just AI things, and for you, and I've realized that for you,
now you quoted from AI.
Yeah, because
wait a minute.
Because with you, we have to discuss using AI.
If you quote from AI,
we have to discuss using. Look, Lloyd. If you come, and
if you quote from AI, can I do a measurement from AI?
Yeah.
So I'm asking a simple question. Yeah. Now wait a minute. You can ask AI.
Yeah.
This is what I want you to ask
The
AI.
whole night I've asked AI questions. When it gets to a point,
Wait a
you
minute.
want
We can
it,
solve this.
you want me to ask a question of it saying yes, yes. But when I ask it by how big and it says ineligible, you then say like, what source are you reading from? I don't know what. I
Wait a
don't know
minute.
what. Like,
Wait,
like,
but wait a
like.
minute. It's easily. That's easily confirmed. All you have to do is ask A this. If I got 330, if I got 380 solar panels in parallel, what is the amperage out? And say LED. Say I'm using an LED light to put on low light solar panels, the same ones that's used in the solar calculator.
Lloyd, I'm going to ask it the way you want, because I know that is how you will not argue again. But for me, to be honest, I was believing you most of the times. But now when you just said that 0.79 amperes is 79 milliamps, I was like, I think Lloyd doesn't know what he's doing actually. But let me ask the question.
It doesn't know.
You the one who doesn't know these things, you confuse them. For me, I might not know how to set up those things, but I know the math of it.
You know why it doesn't know? You know why it doesn't know? Because you didn't give it the number of the cell.
No, you
You see, that's what I'm saying. You're just throwing out numbers, but you're not giving it enough information to tell you. I'm asking you to do something very simple.
Lloyd, look. This video of yours is like from 2 years ago. If you are really doing like something that actually works, I think you could have a product by now. Because there's a guy, there's one viewer of mine who got mad at me because he was telling me that
you just went into another search. You're just telling me.
I come to a show and you're just repeating the same thing. Lloyd, you're just repeating the same things.
Months to do a product, and you don't know business.
Okay.
There's no way you're going to run a business in a couple of months and just get a thing. If so, then why aren't you doing it?
Because it doesn't work, this one. This thing you're doing doesn't work at all. But let me ask you say that I ask it if...
Okay, first let's establish the question.
Yeah.
We're using LED lights.
Yeah.
Right? Using LED lights.
Yeah.
Correct?
Yeah.
Okay. And I wanted to give it a reference. I'm going to give it a reference video so it gets it correct. Here's the reference. I'm going to send you over the reference video. And this video here. Why did you do that? Okay. Share. And I'm sending it to you. Okay. So this is sending it to you. So, okay, this is the reference video that you add into your question. Okay? Because it's showing the apparatus there. So if I take 380 small solar panels, which is shown in the video, using LED lights, which run on 5 watts of power, and I put all those solar panels in parallel, what is the amperage out?
Okay.
And wait, and before you send it, don't send it yet. I'm gonna show you, because I'm gonna give this store-bought so you will understand what each of the solar actually puts out, so we don't get confused. Okay, so put this image in there. Do you see from the store it says 2.3 volts and 27 milliamps for each one of those solar? Did you see what I sent you?
Yeah.
Okay, so put both those in there. It says this is how you give it all the information. The information is now we know what the voltage and the amperage of each cell is. If we put 380 of them, which is the span of the 16 feet of the solar panels, that means 149 or something on the left side and 149 on the right side. So we end up with 300, and I always round it off. 380, but we round it off to 300. So if we take 300 of those low light cells that only puts out 27 milliamps, put it all in parallel, what is the amperage put out?
So I say that if Lloyd, if you put, I say that if you put 5 watts, 5 watts, right?
Yeah, wait a minute. The LED light is 5 watts. You don't say 5 watts. Say the LED light is running from 5 watts, just like the reference video in which we gave. That is running on 5 watts. We have 16.4 feet of that LED rope light, meaning that along the rope light on the left and right side, we can put a bunch of solars. It can equal up to 300 solars in total on the right and left side of that 16 feet of the solar.
Yeah, I'm writing.
If we put them all in parallel, what is the amperage output?
Yeah, I'm writing it. Although that 300. What, the one in the video, the one in the previous video, you had used how many? 4? Was it 4? 5 solar panels?
I didn't hear what you said. You said what?
In the video that you had uploaded the prototype, how many solar panels did you use for that one? Was it like 5 of this? Or it was 4 of them?
No, because I didn't do a thing. I just did a demonstration. I only put 8 cells because I just needed 17 volts.
You did not need current, okay. So I've said
right. Not for this experiment. The next experiment was going to be bigger,
300.
which you'll see in the next experiment.
Okay. So if the LEDs are running on 5 watts, if the LEDs are running on 5 watts, lighting up 300. You said 300 or 380?
It's 380 solar cells that's in parallel. And you can see the measurement. Even if this solar cell is a little bit bigger than the one I'm using, because I'm using a 3 millimeter, and this is like a 40 millimeter, but it still will give you the same answer, because what we're asking is that if you put these things in parallel, what is the amperage out, since they're low sensitive LED? These are the same things they run inside your house, ambient light. That's the solar calculators that they use. So if we already know that what they put out in millimeters, so, and it says it, and we saying we put them all in parallel, what is the amperage coming out of for that 16 feet? Because that's what I'm doing. That's what's going to market. I'm not just doing a small little demonstration. I'm doing a full panel. I haven't done a full panel yet.
And so you're saying if now someone used the all full panel outside, if it compared to outside and compared to running it on LEDs will be much better, or it just gives you the option to run it at night? running in parallel.
Right. And it's a hybrid system. That means it needs to get through the nighttime until the daytime. So it needs to run for 12 hours. But if you're drawing in 5 pot and the rope light is 16.4 feet long, and you start to line them up, and remember, I'm gonna show you a picture of, because someone else is doing this, and he did the experiment. I'm just going to give you what he did. Do you see those pictures? So
Yeah.
someone else other than me confirmed what I just said.
He can now, like he's running a refrigerator.
That's a full panel. You're only getting a partial of it. These are full panels.
Okay. So my question is, analyze this video and analyze this video and analyze the image I've provided as well. If the LEDs are running on 5 watts, lighting up such 380 solar cells like the above screenshot, running in parallel, what current will I get from this? Is that okay or should I change it?
No, it's good enough. Let's see what it says.
Let's see what someone says. There's a question for you from who? There's a question for you from Cecile. He was asking like, let me see. You're Nesto. I hope you're doing okay.
Yeah, I'm okay.
There's a question for you. I'm trying to get it from Cecile.
Well, see, the questions that I'm reading in the thing, it says that you can't get amperage from the LED lights. So in the video that I gave you in the reference,
Yeah.
the LED light charging the battery. So here's the point, Chris.
Can I read the answer that I've gotten?
Yeah, what's the answer you got?
It says that based on the YouTube video and the specs in the image you provided, here's the breakdown of what is happening in the video and the mathematical reality of your proposed 380 cell setup. Video analysis. In the video, Lloyd demonstrates another iteration of his closed loop concept. He has a setup where an LED is placed between. He has a system where LEDs are placed between 2 solar panels. He uses the system to charge 2 AA batteries and uses to charge AA batteries, not two, to charge AA batteries, and uses a multimeter to measure their voltage before and after placing them in the circuit. By observing the voltage jump slightly, e.g. from 1.05 volt to 1.1 volt and then 1.12 volt. He concludes that the system works and is successfully charging the batteries using the light from the LED. So, however, as you've not,
that's all I care.
you don't
That's
want
all I care about.
you don't want it to finish the that way. Then it means means for you only read the parts that you're interested, which makes you happy. Like you don't go through the entire thing.
The reason why
Can
I'm
I read-
stopping you is because I want to make.
Can I
wanted to make note.
can I read the entire thing
I know, but wait.
until I get to the
Can we
amperes?
just make sure?
I want to get to the
Yes,
amperes as well.
we'll get there, but I want to just make sure this.
Yeah,
The LED light can do actual work.
yeah.
That means that the questions in the comments is saying that you can only get it from the environment.
No,
But what we just did is take it from an LED light, and we were able to do actual charging of the battery from a source that was in a box.
yeah. The thing is, AI at this point, AI is explaining what you said in the video. It's not like it is agreeing with you or denying with you. It is like saying what you said in the video.
I know that.
Yeah, because
I'm just,
that-
but I'm
that-
repeating that.
That's what
But
you.
the whole point is that you didn't want to acknowledge. I'm answering questions.
That's what you said.
That the LED light can charge batteries without the sun.
Yeah, that is what you said in the video, and AI has said you said so. So now it wants to begin now saying what it thinks is true or not. Yeah? Because for now I cannot just believe you what you say in the video, because you're taking 0.79 amperes and you are so sure 100% that that is
I didn't do
709,
that. You
that is
said that.
79 amperes, and then you say that I said that. Given that you are someone who can just deny something as big as that, like you can't admit something as simple as that.
You are making up numbers.
But
I did not say
okay,
something about
okay,
0.9. You didn't see that on any of my instruments.
okay,
You came up with the 0.9.
okay. Let me continue. Okay, let me continue. Image analysis and calculations. So if it looks at the WhatsApp screenshot you shared, the key specifications for single cell are voltage is 2.3 volts. Is that okay?
We didn't ask about voltage.
No,
That's series.
it is stating the facts first. It's stating the fact that I've provided it. If there is something wrong, before it calculates. If there is something wrong, you can say in advance, then I change it. Before it calculates, I'm using the pro version. It's just stating what I gave it to confirm if it's true or not. Then it says,
yes, that's what's in there. It's
yeah,
2.3 volts,
yeah,
from the solar.
Current is 27
and 27
milliamps or 0.027 amperes.
Now, let me ask you a question.
Yeah.
Let me ask you this question.
Yeah.
Is 27 milliamps over 0.5 milliamps, which you said my system only puts out?
27 amps is below 0.05 amps. You're saying I said 0.05 amps, but that is 50 milliamps. Your system, AI said that your other system was putting out 50 milliamps. To be specific in terms of milliamps, it was 50.
See, okay, you said not 0.5. You're saying 50 milliamps.
50 milliamps.
And I'm saying that
in terms of
so,
amperes, it was 0.05 amperes. In terms of milliamps, it was 50.
Now let me clarify that. If you said it was 50 and you didn't make up the number,
no.
What I'm asking you is, if I got 8 of them and they put out 27 milliamps, what is 27 times 8?
So the good thing is 27, you're saying 27 times 8?
27 times 8.
No, for you, you're not accounting in like that is what you're getting out.
But it's over the number you're quoting.
What you are getting?
I keep asking you where you're getting this number from.
Please listen just a moment. Like what I'm saying, what AI said that according to estimation, what you are getting out of the system after you add 5 watts coming through the LEDs, lighting the LEDs, then going through the solar, what you're getting out of it from the entire 8 of them, what you're getting out of it was, according to the setup that you had, what you get out of the entire thing was 0.05 amperes. Now, this time you've provided the amperage for each solar panel, okay? And the AI now wants to do its thing, and we can see if it will be according to what you said or not. And for right now, it's just stating the facts about that solar sheet that you showed. Voltage 2.23, current of the each panel is 27, yeah?
Yes.
Okay. So it's saying that
and we did say we said we put it in parallel.
Yeah. So
it didn't mention that.
Yeah, if you let me continue, it mentions everything. It even goes ahead to mention that they're showing that according to, if it's used in full sun, I think saying that condition full sun, there's something written there, full sun on the solar panel, on that panel.
Okay.
If it's under full sun, but now it goes ahead to
wait a minute. Can you correct it, saying that we used LED light in the example? Why would you go to full sun when we're trying to calculate what it does under LED light?
Yeah,
can you make that correction?
No, it's you who is not listening to me. Like what I'm saying is, it is stating the fact of what was provided in the image. Like on that image, you see the screenshot you shared. read it at the bottom. You'll see it says full sun, yeah? So it is just stating the fact as it is before it now begins calculating with LED. So in a minute, I'm about to get to that.
Okay.
Yeah. Like it is just stating the facts. Like usually that is to confirm if you did anything wrong or right. So he's saying that if you wire 308 of these cells in parallel, the voltage remains the same, which is 2.23 volts. And the current is supposed to, the current is added together, that is 380 times 27 milliamps. You'll get 10,206 milliamps or 10.26 amperes. That is under the condition of full sun. Is that okay?
No.
That is if you're using
it. We want to know about the LED light.
If you're using
Why
it.
you keep bringing in sunlight?
Yeah.
The experiment was under under
okay.
LED light.
Okay, here it is.
Here it is. Find out what it does under LED light.
Here it is. Here it is. The 5-watt LED. Now that one. Here is where the physics of the loop breaks down the setup. You are powering the LEDs with the only 5 watts of electrical energy. LED efficiency is equals to LED efficiency loss. LEDs are not 100% efficient. A standard LED converts roughly 20 to 30% of electrical energy into actual light or photons. It talks about solar panel efficiency loss. It's saying that amorphous silicon solar cells like the ones in your image are quite inefficient. Usually only converting about 5 to 10% of the light.
We're going through everything but what we asked the question of. The question was,
we're getting to it.
Under LED lights.
We're getting to it. Just be calm. Just be calm. You're going through the facts, the output math. Let's assume a generous best case scenario. Your LED output 1.5 watts of pure light and 100% of that light perfectly hits your solar panels. 1.5 watts light times 10% solar efficiency is equals to 0.15 watts of total electrical power generated by the panels. Using the power formula, power is equals to current times voltage. You can find that the current is we can find that the current will be 0.064 amps or 64 milliamps. Conclusion. With the 380 solar cells wired in parallel, if your light source is only 5-watt LED, you will not get anywhere near the 10.26 amps that these panels can be able to generate under the sun. You will likely generate less than 100 milliamps or 0.1 amps. This mathematical bottleneck is exactly why the looping energy concept doesn't generate net power. You put 5 watts of electricity into the LED, and because of conversion losses, heat, and poor solar absorption, you get a fraction of a watt back out. That's what it says.
Okay. So, first of all, it did not stack the amperage. I don't care if it dropped it down to 14 milliamps or 5 milliamps. But you can't say you're getting only 100 milliamps out of 380 solar panels.
Look, for you, you're assuming like each solar is going to generate 27. No, it's written that under full sun. It's able to do that under full sun.
No, you keep bringing in. I just told you
let me put this image on the screen because I think.
Dude, I'm going to put the image. You got to understand. I'm going to take your videos and what you said.
Yeah.
I'm going to do the AI, and I'm going to ask the question.
Yeah.
Because the simple fact is, I know for a fact that it's going to be at least 5 amps when you put it in parallel.
It's okay.
And you didn't want to read that.
No.
You didn't want to read that.
I did not want to read that how, and I read the entire thing that AI has shown me on the screen, everything including what I gave it, and you are not agreeing with it. You just want me to agree with you, like yeah. You don't want me to say what I'm saying. You're turning.
I'm finna go to your channel. Wait a minute. No, I'm finna go to your channel.
Look.
This is what you're not, and I want to see if you read this.
Look on
at your channel.
Look on the screen. Look on the screen. I've shown what you shared.
Nothing on my screen. Hold on.
what you shared with me. I've shared what you said. This is what Lloyd shared with me. In case he comes and reacts to this video, it should show this part as well. Here it shows that this is under full sun. It does 27. This solar is able to produce 27 milliamps under full sun. It is not. But Lloyd is assuming that the solar itself will just generate 27 milliamps without doing anything.
Wait a minute. So why didn't you share this? Why didn't you share this?
Which one?
Go to WhatsApp and tell me why you didn't show this.
So these are the things you ask AI on your own. I don't know how you ask them. Then it gives you.
So then the point was that you put that. You copy this.
Which version are you? Which version are you using? If Lloyd goes to react to this video.
I'm using Google. I'm using Google, and I can send you the link to the Google.
Okay. So
I'm asking you to copy and paste this into it and said this is what Google AI said. But you didn't want to show both sides of the story. So why didn't you show this?
Let me do that right now as well. I'm 100% sure what it will say. You will still do what? You will still not accept, but I'm gonna do that. So I want you guys to see. Lloyd say that he's using Google. I just want to be I'm using Google. And also I want when Lloyd is picking this part, when Lloyd goes to pick this part for his video, I also want him to include this, that I'm also using Google, and Lloyd is using Google Flash model, and I'm using Google Pro version. Pro version is higher than the Flash model. I just want him to include that one. And you can see on the screen in this section, you see it shows Pro, and thinking level, I'm using extended version. I'm just taking the question that Lloyd is asking me and putting them here, and it shows me the results, but it doesn't accept. So let me copy this one and also put it, and we see what it says. Because for some reason, for me, when I ask AI, it doesn't agree with what you say, and I'm just asking the same question that you are telling me to ask. I'm not changing, I'm not editing anything. But
it seems like you are, but okay.
But you somehow you don't want to accept. So you can see the screen, right? I'm just going to paste it. This is the message that you put, yeah. So you want me to ask if this is true, or what do you want me to ask this? Because I think this conversation of yours with AI began from a question.
What was your question?
Like this message that you shared, you said that I put it into my AI, and it is a conversation between you and AI. So like, how do you want me to format the question?
You see what I said? I just wanted to confirm. I sent you the whole entire link. What does it say? Does it say Gemini?
Yeah, it says that you're using Gemini, the Flash model.
Oh, okay, so we got that cleared up.
Yeah.
Okay, so if we're using Gemini,
and
you can read it because let me explain what happened in the conversation.
Yeah.
I started going to all the other AIs and let them battle it out, because that's what the new AIs do. It takes all the AIs, start grouping them together, and then they come up with a conclusion. So the whole point is that when you start seeing in my video that I can actually do physical work of charging the battery.
Yeah.
The battery needs amperage and the battery needs voltage. So if it charges the battery in the system and we add 300 of those, 380 of those into the same LED light, which is 16 feet, and you said, oh, we're only going to get 100 amps out.
AI said, I did not say, AI said, it is here on the screen. It is AI that said, stop saying that I said. AI said, I was reading the same thing that your AI says. We're just using AI. So Lloyd, we're just using AI and it's giving us wrong answers. Why can't you just measure it and show us? Why can't you just measure it and show us? It will be better.
Let me tell you the same question. I'm just reading from my AI. But you didn't show what my AI said. You only show what your AI said, and you believe your AI because it carries your scenario. I believe my
Then
AI.
it means your AI carries. It means you ask your question. You ask your question for the AI to carry your scenario.
But your AI is right.
No, mine I just ask it
That's
like
what you've been trying to say.
I just did ask it like I'm asking the same question you are telling me to ask. I'm not changing anything. I'm just putting it there. And even when you go to clip it, you'll see those questions on the screen. I'm just putting them there. I'm not changing anything. And I'm going to show the I'm going to show your conversation on the screen as well. Then we can see how you see.
Show it.
Yeah, I'm going to show them. I'm going.
I'm saying the same thing that you're saying. I'm saying that I'm showing you what the AI told me. So if we're both saying the same thing and we're using the same AI, then it's the questions being asked right. Because remember, what I did is I challenged another AI, which says it was wrong, is giving the answers you gave, and then I gave it back to Google. And Google said, this guy doesn't know what he's talking about because it's using old technology because how it was explained. So when you read that, you see that it's saying that the other AI has gotten this wrong and you pinned it down. So read that to everybody or show it on the screen and then say, okay, maybe we're doing something wrong, because we're getting two different answers from the same AI.
So
does that make any sense?
Yeah, it makes total sense. And I also said that I understand why my AI and your AI, they're showing us different results. And I wish you could just measure. And
I do. And guess what? I'm going to measure it.
Yeah, if you can just.
Now I'm going to put it on a video. Yes. And I'm going to say, oh, but you just said it don't produce amps.
Yeah, then remember to read those.
No, I said amps.
Remember to read.
Amps.
Yeah. You said 79 milliamps. And the other side, but Lloyd, for you, I think Lloyd, for you, what was I going to say? Like you said, milliamps this side where you have the power supply, you're reading 0.79 as 79 milliamps, and then on the other side, on the MPPT where you have 0.42 amperes, you're not reading it as milliamperes, you're reading it as amperes. Dude, you
go back and listen. I said milliamps. I said milliamps right on the show. You can go back and listen. I said milliamps.
Yeah, okay. Let me go back and listen. Let me show what you shared first. Then I'm gonna play it as well. I'm gonna replay that side. Yeah. We agree on that one. So what?
That proves my point, because it is milliamps. But when you go and say the voltage times the amperage, it reads the wattage over the top of it.
No.
Which you didn't really want to talk about, because it said 19 watts. And watts is what counts.
Which one said that? No, Lloyd.
In the video, it shows the wattage.
Lloyd. I think what you do, you are like good at what you do, but you have issues with reading the. Let me replay this video of yours. You see, even yourself, this is 0.7. When Lloyd comes to clip this part, please show this part as well. This is 0.79 amperes, but Lloyd says this is 700 and he says this is 79 milliamps at first. Then he said that it was, before he accepted that it was 790 amps. Now, when Lloyd goes to this, when Lloyd comes here and we have the same value of this is 0.052, he will not read it as amps, he will read it as milliamps.
It's automatically going to put that back into the battery. 7 watts. That's about
said 79 milliamps. You draw the hair and says, no, it's 700 and something milliamps. That's not what it shows because it doesn't go to all those zeros.
No.
So just because I say 79 milliamps, I'm still talking about milliamps.
That was wrong.
You try to go to ChatGPT and said, well, see, it don't have an extra zero on that meter.
That is
So why would I read it like that?
that is wrong. This is not 79. This wasn't 79. That was
Okay.
that was zero. That was 790. 790. You have to convert by a factor of 1,000.
No, I don't have to convert. I can just read what was on the meter.
That way you're reading it wrong,
know
man.
why?
You're reading it wrong. You're reading it wrong,
You
and,
know what?
you're,
I'm not reading it wrong. You want me to read it wrong because if I was reading it wrong, I wouldn't have said milliamp.
oh
I
man.
wouldn't have
Oh
said
man.
milliamp. Let me explain something so everybody can hear this. When people say 2.3 and it's actually 2.36,
Wait.
they're
What?
saying the same thing.
Do you see the screen?
When people are reading, because they're dropping off that extra one, it doesn't change what we're saying. We're saying that we know what the extra zeros are on there, but it all equals out to 2.3. And many people do this. And when I do the videos, I take what you say and I go and say, why is this guy saying 2.3 when it's an extra zero? Why is this professional saying 2.3 when it's an actual thing? So when you learn from the professionals and they're doing the same thing, and you're drawing a hair
No.
about, oh, you read it wrong because it was 790 milliamps, and I'm just saying 79 milliamps
Yeah.
because it was showing 79 milliamps.
Lloyd.
And you like, do the conversion. Guess what? We're still in milliamps. It's less than an amp, and that was my point.
No.
Your
Your point is totally wrong. Like wrong 1,000 times. There's something called I think in primary school we used to learn something called significant numbers. Yeah. So if a zero comes before a number, yeah, that number is not significant. It is insignificant if a zero comes before a number. But if a zero comes after a number, that value is significant. But if a zero comes then before a point, if you have 0 point, you cannot ignore the zero unless like you're not right in your head or you never did any math. If it's 0 point,
you're putting words in my mouth. I'm not ignoring it. I'm just reading what was shown on the meter.
Delvin energy. What you're talking about is it was 0.9, is 0.79, and Lloyd said 0.79 is the same as 79 amperes, which is wrong. 0.79. I mean, he said 0.79 is the same as 0.7 is the same as 79 milliamps, which is wrong. 0.79 is 790 milliamps.
Wait, no. Let's do this. Since you didn't want to show that first, let's go back to Google, show it the image, and ask, is it correct if a person says 0.79 milliamps? Or they can't do that or say that because it's totally incorrect. They must add in the extra zeros. Ask it, can it be said this way or can it be said both ways and be totally correct? If you ask that question to AI, it'll let you know from the image. If it only shows 79, you can say 79 as long as you stay in milliamps. Ask that question. And guess
Lloyd,
what? Guess what's going to happen? It's going to say, yeah, that's correct because the instruments don't go to those zeros. So you can say.
Look, the entire day today I've spent it as like asking AI all your questions. But what you're saying?
No.
What you're saying is different. What you're saying is different. What you talk?
You know why?
Look,
you know why I'm saying this?
Delvin.
Because the way you're saying it, for everybody to understand.
Look, yeah, everybody.
See,
on the screen. Pi has
a lot of zeros and numbers behind it. No one quotes all those numbers.
Lloyd,
And you're trying to say because they don't quote those numbers that they're wrong on
no,
what they
no,
say.
no, no,
So
no,
when
no,
I
no,
go
no, no, no,
wrong,
no, no. That's not what I said. What you said,
then why are you
we have
using
on
my
the screen. You
case?
can see on the screen. On the screen, I have 0.79. That 0.79, I said 0.79 is amperes and not milliamps. For you, you said it is 79 milliamps, which I said that is wrong because you're converting from amperes to milliamps. And if you're converting from amperes to milliamps, you're supposed to use a factor of 1,000, not 100. For you, you're using, I think, for you, you're using 100. You're taking that point.
No, I'm not.
So if you don't know any math, Lloyd,
But
when
I'm
it
not.
comes to decimals.
I'm just reading
Let,
what was on the meter.
let me
And I'm telling you that's what
even
I did.
it is even on the screen. Like, it doesn't make sense to argue with you, man. Just like you don't
I'm
maybe
taking the screenshot. I'm
maybe
taking the screenshot because it says
all
right on the
questions
screen
all questions I've asked today were your
0.79.
question.
That's all I stated.
Let me replay the live. Then you see what you said. Like for you, you have this thing that you say it is what you said, but you keep on. You can also use this moment to learn how to read units of amperes, man. There's no way.
Dude, you telling me I didn't say 0. Is that what you're saying?
You said it was 79 amperes, 79 milliamperes. You said that it was 79
No.
milliamperes.
I'm asking you specifically. I didn't say 0.79.
Let me just.
I didn't say that.
Let me just replay that part. We stop arguing.
Because I
Let me
can't hear it on this end.
let me no, I'm trying to open the live stream. Even there's a guy called Delvin Energy in the stream. I think he supports you a lot, but even acknowledges. But if you're converting from amperes to milliamps, you have to convert by a factor of 1,000. You multiply by 1,000. So if you take 0.79 times 1,000, you get 790 milliamps, not 79 milliamperes. But let me just go to that point on the stream. Let me put it here on the video. I don't know which minute it was.
So let me answer identity. So when you see on the screen, which you're looking at now, it says 0.79. Are you saying you must say 790 milliamps? Is that what you're saying?
If you say 790
or can I read it? Can I read exactly what's on the actual instrument as is and say milliamps?
You say 0. So if you're saying 0.79 milliamps, you're wrong. That's what you are saying. Actually, that is what began this whole argument. You are saying it was 0.79.
He said, yes. Can you clarify? See, and he says, or 0.79, and it's milliamps. So you can say it both ways. Even identity say you can say it both ways.
ID saying that you can say it as 790 milliamps or 0.79 amperes, not 79 milliamps. Lloyd, you maybe all the time I've known you, you've been correct on most of the things. But when it comes to reading this unit today, today you are not.
All I'm saying is that I was reading what was on the meter.
You are not correct.
The meter showed 0.79, and it's in the milliamp range. So I said 79, 0.79 milliamps. It's in the milliamps. It doesn't have an extra zero there. So I read what was on the instrument. I knew what we was talking about milliamps because we're not talking about a full amp.
So you still have that issue that if it's not a full amp, then it cannot be 0. Like
That is not what I'm saying.
What you say? Let me replay the live stream. Because I'm already here. and you listen to you.
Because
Just
it's
listen to you.
0.
Why can't I replay until you listen what you said? Because like now you're trying to make it seem as if I'm insane. I had some other things. For this system that you're showing me, this one is outputting power of 24. But
wait a minute, let's slow down. Let's slow down. Did you see the picture I sent you of the system?
The one that you're saying that you're still setting up? Yeah, I did.
So I changed it, right?
So basically, what you're trying to say is what you have right now doesn't work, and what you're changing to is what will work.
No. What I'm saying is one does a bottleneck, and to fix the bottleneck is at the second charge controller. So I changed it to the second.
Let me just play it, then you listen. You will see what you said.
No, I was talking to identity.
Okay.
Charge controller, because it doesn't allow it that 37 microamps.
It's putting in 0.6. No, it's showing it. Wait, it's putting in
0.79 is a milliamp. It's not a full amp.
That is 0.79 amps, yeah?
That's milliamps.
No, that's not me.
He doesn't want to read what I sent him from Google. That's why we're going through this.
Have you seen that one? You said 0. Now you're turning it that I don't want to read from what was on Google after you realize you said it.
Well, that was what the original.
Let me play.
I'm just reading.
Let me show you what you said on the Google anyways. Let me show. But you have heard yourself saying so. You said 0.7. You have heard yourself say so. Or I replay it again before I show you what you sent on Google.
Okay, what did I say? Let's hear it.
It's actually putting in power, not voltage alone. It's putting in power.
It's putting in microamps.
It's putting in 0.6. No, it's showing it. Wait, it's putting in
0.79 is a milliamp. It's not a full amp.
That is 0.79 amps, yeah?
That's milliamps.
No, that's not milliamps.
0, it would be a 1 there. I can't hear it. Are you playing it?
Yeah, I've been playing it. I think they can hear it. I think you just move. Can you guys hear it? I think you can just
look.
The stream is behind. Just move the slide ahead. You will hear it.
Did you see what Identity just said? Did you see what Identity said in the comments?
Yeah, he's saying based on the image, it's reading amps. You can convert that number. It's reading amps, not MA. You can convert that number to MA, but you multiply 0.79 by 1000, which makes it 790 milliamps. 790 milliamps. Man, that's what I've been saying all along. For you, you're saying something else. Now you're coming and say that I was wrong.
Wait a minute. So the whole point is that you see that 0 and that point. Anything before that 0 is 1 amp. Anything after that is milliamps.
No.
Which I've been saying.
No.
I've been telling you that I said 0.79 milliamps. That's what I said.
Lloyd, you have an issue, and I think like there's no way I can convince you about this. This is something you learn, I think, in where I am. We call it primary school.
But when we show this to the engineers that I've been talking to, they're going to have a good laugh because it was like he's trying to divert on what was actually saying, because now you're saying amperage don't stack, and to get on an issue about me saying 0.79.
Yeah,
which is
you're saying look,
you're showing me a picture of the actual numbers and just saying, well, that's not what it means.
No, it
says 0.79.
All I'm saying is 0.79 is the ampere, and you're saying that you cannot have an ampere if it's under 0 point, which doesn't make sense.
I never said it was.
Okay.
I never said
Okay.
it was an
Okay. 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 What is the value? What is this number on the screen?
0.79.
Yeah. What unit?
That's what's on the
What
screen.
what unit? What unit?
0.79. That's what's on the screen.
What is the unit? We are talking about current. What was the unit?
I'm not. No, you asked me what was on the screen.
Okay,
I'm gonna
okay,
tell you what's
okay,
on the
okay.
screen. That's
Listen,
what I said in
listen,
the
listen.
video.
This is what Lloyd will not show you. If you pick this video, please play this part. This is what you said was on the screen.
It's a full amp.
No,
It is
Lloyd,
after that. It's
Lloyd.
a point there. It's milliamp. That is 79 milliamps.
That's Lloyd. That's
Everybody
Lloyd
see
saying
what's
that
on the
is
screen.
79 milliamps. That's 79. I said specifically that's 79 milliamps. Dude, that's not 79 milliamps. To convert from amps to milliamps, you have to multiply by a factor of 1,000.
You okay?
Man,
Okay.
you.
You know what? Everybody can see what that's a new point because everybody can see what I did.
Even your guy who believes
Soon
in
as
the
you
comment
said,
section
wait a
delving
minute,
energy is
Soon
saying
as
the
you
same thing.
said,
I don't know what
as
is
soon
wrong
as
with you,
said,
man. I don't know
said
what is wrong with you. Why can't you just see this small thing? Like a simple.
It's a mute thing. As soon as you said, I said milliamps.
You said it.
Okay.
You will
So
listen. You will hear it
all I'm saying
in the live.
is
My live stream is
the
about to
whole
end.
point is I read was on the meter. And I kept it in the milliamp range.
I'm saying that
you were trying to draw straws, little despairs, and just said, well, you need to convert. No one does that.
I don't say that it is a must to convert it. What I'm saying is you have to read the right way. You don't say that 0.79 amperes is milliamps because then it doesn't make sense even for you, Lloyd. It doesn't make sense that here when you are reading what was coming from.
Okay.
Look, when you are reading what was coming from the power supply, you read it as 0.79 milliamps, but then when you went to read what was on the screen, what it was showing on the screen, you instead went and read it as 0.42 amperes. Like it doesn't make sense. Like what is happening here? Because it is the same value, but you're reading the other one different, and this one you're reading as amperes. In your own video, you read this one as 0.42 amperes. You even say that it's going up. But now this other one, your mind is telling you that now this other one is now milliamps.
Now let me wait a minute. I want you to do a quick math. This is how you learn.
No, this is how you should learn. You're not learning. You're refusing to learn. You're refusing to learn. This is how you should learn. It's not like you know. It's not like you know. It's not like you know everything, Lloyd. This must no.
I said,
you look.
Go back to the screen.
You know.
Please go back to the screen. Don't hide it.
I'm
not hiding.
I'm not hiding. I'm not hiding. Look, what I'm saying is.
Then why don't you want to show it?
What?
Why don't you want to show it again?
Show what?
Go back to the screen where it shows the voltage, the amperage, and the wattage. Go back to the screen.
Yeah, that's why I'm saying I showed you and I said that it doesn't make sense for you to come here and say that this is amperes and the other one you're reading it as milliamps. Like.
But I'm gonna tell you why I said that.
Okay, say.
Why don't you put it back up on the screen?
It is on the screen.
Go back to the screen.
I've shown it.
Yeah,
maybe on your side there's some delay. I've shown it.
Right there. Wait a minute.
Be quick. So the live is about to end in 4 minutes. Be quick. In 2 minutes.
We have 37 volts times 0.42 amps.
Yeah, why do you read that as amps? Why do you read that one as amps? And the other one you're reading it as milliamps.
5.8 watts. So divide that wattage. What do you get to get to 5.8 watts? How do you divide that up? Then you'll know what is said down there at the amps.
This is amps. It's showing here 0.42 amps. Yeah.
So how many watts is that?
This is.
So how many watts is that?
This is 0.42 watts. Like it is reading.
Wait a minute. You said you're gonna do. Wait a minute. No. You said you're gonna do the conversion. So what is the 0.0 of 15.8 watts. What does that convert to?
This is showing that the voltage is 37. You just take 37, you multiply by 0.42, you'll get
You're not going to answer the question. You're not going to answer the question. So there it is there. I'm asking
No,
you
because
about the wattage.
I don't understand your
Which
question. I think your question is somehow stupid or something because I don't get it. You're asking like zero. You're asking this wattage of 15.8 watts. This wattage you're going to get it by taking the product of voltage multiplied by current, which is 0.42 times 37.5. Or you want me to do that so that you see you get 15.8.
So you just said it was 15.8 watts.
Yeah, it's coming from the product of amperes, which is 0.42. It's either 0. Because it is fluctuating when you play your video. The subsection it was 0.42. It went up to I think 0.46.
So now here's the question. Here's the question that I'm
Yo,
saying.
my life is
The
about to end. My life
battery
is about to end. My life is about to end, and my life ends in
Okay.
2 minutes.
Let me finish. Then let me finish the
No,
statement.
it's going to
The
end on
reason
its.
why I said that is because the battery itself is putting out 3 amps. So that 3 amps must disappear and not showing up anywhere in this system. But yet we're getting to the 15.8 watts shown. So that means that it had